Okay, so we are going to start the next lecture on unit number 2. Today we'll be having 2 hours lecture. So maximum things will be covered today of unit number 2. So although as the university has declared that your B exams will be physically conducted, so you need to be very serious while and attend the lectures, because I'm seeing from last few lectures the attendance is very low. So if you want to understand something from AI, at least you should be able to attain all the lectures, and that only then only you will be able to understand or write something. So as the physical exams will be there, each and every type of questions are possible that can come in the exam. So you need to understand each and every bit, because see, when a bit is written there in the syllabus, it doesn't mean that only that bit. That bit carries a lot of information, lot of sub parts. So in similar way, only problem solving through search is written in your unit. But with that, informed and uninformed type of search and all those things are never written. So in order to understand all these things, what could be the sub parts and what can come in the exam, you need to attend your lectures very regularly. So I am expecting that the B strength will be more and more, because from last few lectures, I am not at all happy with the strength. So hope that will keep on increasing. So we'll just have a flashback within 1 minute, what we have seen up till now. We have seen what is problem solving through search. Then we have seen some of the most common problems resolved by AI. That is the traveling salesman problem, Tour of the Hanoi problem, water jug problem, NQN problem, chess, Sudoku, crypt arithmetic problems, magic square, logical puzzles, and so on. And then we have also seen few steps that are involved in the process of problem solving using search. That is defining the problem, then analyzing the problem, identifying the possible solutions, choosing the optimal solutions, and then the implementation. These are some of the properties of search algorithm we have seen, that is completeness, optimality, time complexity, and space complexity. Then we have seen there are two types of search algorithms. One is an uninformed search algorithm and the other one is an informed search algorithm. So uninformed search algorithm is also called as a blind search algorithm or brute force algorithm. Then in case of uninformed search algorithm, there are 6 types of strategies that are used. One is a breadth first search, depth first search, depth limited search, iterative deepening depth first search, and bidirectional search, as well as uniform cost search. Then we have seen the breadth first search. So I'll directly go to the informed search, because we have already seen that. Now, in case of informed search, there are 2 strategies that are mostly used here, is the greedy best fit search algorithm and A star search algorithm. And here the goal state is achieved by using heuristic function. That is what the difference is about. Then we have seen the greedy best fit search algorithms. Then we have also seen the A star search algorithm. And we have also seen the comparison of uninformed and informed search algorithms, right? So last time what we have seen is up till this. Now from here, we are going to see one of the new search techniques called as heuristic search techniques. So this is completely a new type of a technique, like uninformed and informed search technique. It is also one of the popular techniques. The most important thing about the heuristic search is it upgrades the issue by iteratively improving the arrangement dependent on a given heuristic capacity or cost measure. So obviously the most important thing is that it keeps on iteratively improving by calculating the heuristic capacity or a cost measure. So we have seen how the heuristic function works out. This technique doesn't generally ensure to locate an ideal or the best arrangement. However, it may rather locate a decent or worthy arrangement inside a sensible measure of time and memory space. So this technique also makes a very sensible use of the measure of a time and memory space. So that was not in the informed or uninformed search. So here it is a very makes a very sensible use of measure of a time and memory space. Beyond that, it is also very much an optimality, culmination, and exactness or accuracy for the speed. It is a sort of an alternative route as we can regularly exchange one of the optimality. It finds the foremost promising path, like informed search. It takes the present state of an agent as its input and produces the estimation how close agent is from the goal. This is also one of the most important part of the heuristic, is that it considers the present state of that agent as its input, and then it keep on estimating about the close agent in the is from the goal. So it will estimate about the goal. So it will take the present state of the agent and it will estimate the state of a agent from the goal. That is what it does. The heuristic or heuristic capacity investigates search calculations. So it does the calculations about how the search should be carried out. At each stretching step, it accesses the accessible data and settles on a choice on which branch to follow. So obviously, it already calculates the whole investigation about the search, and then it settles on a choice about which branch to be followed. It does as such by positioning other options. So it also not only helps to find out that thing, but it also helps to settle the choice and which branch to be followed. The heuristic is any gadget that is frequently successful, yet won't ensure work for every situation. So obviously this heuristic technique is very much successful and is frequently used as well as frequently successful, but it cannot ensure you that in each situation it would be successful. मतलब जितने सिचुएशन में वो यूज होगा वो 100% सक्सेसफुल देगा, लेकिन हर सिचुएशन में यूज होगा ही, इसका कोई गारंटी नहीं है. We need heuristic in order to create in a sensible measure of a time an answer that is sufficient for the issue being referred to. So I've already said that the heuristic very much sensible to measure the time and space. It doesn't need to be best as estimated arrangement will do, since this is sufficiently quick and most issues are exponential. So this type of technique is a very quick technique, and it will be applicable to those issues which are exponential in nature. So for those issues, heuristic gives you the better results. Heuristic is a technique that is used to solve a problem faster than the classical method. So the other methods as compared to heuristic are not as fast as heuristic is. These techniques are used to find the approximate solution of problems when classical methods do not. So when you apply classical methods, you don't get a result. There is an other option of heuristic, which will always give an assurance at least to give a practical problems solutions. So there is an approximation solutions of a problem. Heuristics are said to be a problem solving technique that results in practical and quick solutions. So obviously the same thing, practically good in the situations where it is possible to solve those situations, whereas in some of the situations where it is not applicable, it will not give you the assurance. Heuristics are strategies that are derived from past experience with similar problems. So heuristic takes helps of the past experiences, that what it has done in the past situations, exactly it will try to follow in the similar way when that type of situation occurs in the present. So it is like solving similar type of problems in with the same situations. So at that time, heuristic is very much useful. Heuristics uses practical methods and shortcuts to produce the solutions that may or may not be optimal, but those solutions are sufficient in given limited time frame. Now the question arises, why we need this heuristic search? So heuristic are used in situations where there is a requirement of short-term solutions. So जहां जहां पर short-term solution की जरूरत पड़ेगी, वहां पर आपको heuristic search काम में आएगा. It will not be good enough for long-term solutions. It will be very much useful for the short-term solutions. On facing complex situations with limited resources and time, heuristics can help the companies to make a quick decisions by shortcuts and approximated calculations. So it can handle complex situations very well where there is limited resources and time. In such situations also, it can help companies for a quick decisions and approximated calculations. So that is why we need this, because the question arises always is that why we need these techniques, search techniques. So as we have seen about informed and uninformed search techniques, now we are seeing the heuristic search techniques. So it is the situation where the heuristic search techniques can be useful. They are very quick, they are very fast, and as per the requirement, they can be operated in different situations. Very frequently they gives a result in the situations. In some of the situations it may not work, but it will not give an assurance that for every situation it might work. But yes, for most of the situations, frequent situations, it will give you quick decisions by using shortcuts as well approximate calculations. So this is very, very important, and most important thing is that it will be useful when it is used for the short-term solutions. Most of the heuristic methods involve mental shortcuts to make decisions or past experiences. So obviously the thinking that has been put behind to take decisions for a particular problem, the thinking will be similarly calculated as heuristic can do, which will help to make decisions on past experiences. So mental shortcuts, like what it used to be think at that situations mentally, so similar it will try to take the decisions with the help of its past experiences. Based on the context, there are different heuristic methods that correlate with the problem's codes. So obviously there are different heuristic methods that it will try to correlate with different situations and the scope of the problems. So depending upon the scope, it will try to use different heuristic methods in different situations or in different problems. The common heuristic methods are trial and error, guesswork, the process of elimination, and historical data analysis. So this is the most important line, I do feel so, as I could say that this could be the punchline of the heuristic technique, that कैसे काम करता है वो ना, वो काम कैसे करता है, ऑब्वियसली ट्रायल एंड एरर पे काम करता है, गेस वर्क पे काम करता है, द प्रोसेस ऑफ एलिमिनेशन पे काम करता है कि भाई जो काम का है वो रखो, बाकी का एलिमिनेट करते चलो, और हिस्टोरिकल डेटा एनालिसिस पे काम करता है, क्योंकि वो हिस्ट्री ऑफ डेटा इज वेरी गोइंग टू बी इंपॉर्टेंट, बिकॉज दैट विल हेल्प यू टू गेन द पास्ट एक्सपीरियंसेस, हाउ टू give decisions in those problem situations which are similar in situations. So on that occasions, it is going to give you the exact solution with the help of its past experiences and historical data analysis. So this is the by far the most important line of the historical method. These methods involve simply available information that is not particular to the problem but is more appropriate. So what kind of information it will require to take a decision in a particular situation? So it involves simply available information. जो भी information available है वो simple available information वो लेगा. That may be not particular to that problem, but yes, somewhat like similar to the situation, similar to the problems that could be helpful to take the decisions. So in that way, it is able to, it will be able to take the decisions with the help of trial and error type, guesswork, eliminating some of the points, and then historical data analysis. These methods involve simply available information that is not particular to the problem, but must be most appropriate. They can include representative, effect, and availability of heuristics. So that is why we need the heuristic search. Now, what are the different heuristic search techniques? What are the techniques that are coming into this? So you can see that the heuristic search algorithms in artificial intelligence are mostly of four types. It has two categories under which all these four types will be uh, assigned. So what are the four types that will come into heuristic search? First is the hill climbing. So we are going to see these algorithms. Constraint satisfaction problem, which is also called as CSP. It's a different topic given in your unit, but as it comes under heuristic search, we are going to see under this. So we'll not take it as a separate point. We are going to take under this only. Heuristic satisfaction problem, that is CSP. Then simulated annealing and best first search, which we have already seen in the informed and uninformed type of search algorithms. So the uninformed type of search algorithms, we have seen BFC, that is the best first search. So वहां पर हमने breadth first search देखा था, limited first search देखा था, है ना? So इसमें best first search type का ही एक किस्म का type है, that is called as the best first search. So these all four types comes under the heuristic search in AI. But as far as the categories are concerned, the heuristic techniques comes under two categories. One is a direct one and the other one is a weak one. Now, what actually this direct heuristic search works, where it comes under, that is nothing but direct. And the second one is a weak. So you're going to differentiate the algorithms that comes under this heuristic search in direct and weak. So all these four will be accordingly to the two categories that has been defined here. So one by one we are going to see, but let us first of all see what this direct and weak heuristic techniques means. They are the two categories that are included in the heuristic techniques. So let us see the first one as a direct heuristic and the second one as a weak heuristic. In a direct heuristic search in AI, it includes blind search, uninformed search, and blind control strategy. Yes. So we have already seen blind search. We have already seen uninformed search. So वो सारे जो चीजें हैं वो direct heuristic के अंदर आएगी. देखा हमने already वो. These search techniques are not always possible as they require much memory and time. So ये जो सर्च टेक्निक्स है ये पॉसिबली हर बार ही काम करेगी ऐसा नहीं है, क्योंकि जहां पर आपकी मेमोरी रिक्वायरमेंट बहुत कम है, टाइम भी बहुत कम लेना चाहिए, उस जगह पे फिर डायरेक्ट सर्च काम करेगा ही, इसका कोई गारंटी नहीं है. So this is not always possible to utilize where there is requirement of memory and time. These techniques search the complete space for a solution and use the arbitrary order of operation. So it will try to search the complete space for solution, यानी कि पूरी तरह से solution ढूंढने का काम करेगा और use करने की कोशिश करेगा arbitrary order of operations. So direct search is going to use the complete space for the solution. The examples of direct search techniques may include breadth first search and depth first search techniques. So हमने देखा है informed uninformed search, हमने देखा है blind search, हमने देखा है breadth first search, हमने देखा है depth first search. So direct heuristic के अंदर actually वो सारे आएंगे जो हमने already पढ़ाई की है उनकी. So it includes BFS, DFS और खास बात यह है कि एक चीज उसमें थोड़ी सी एडिशनल है जो कि है blind control strategy. So it is like a blind search only, but you're controlling the whole process through a blind control strategy. Then comes the second one as a weak heuristic search techniques that comes under AI. It includes informed search. So देखा डायरेक्ट में अनइनफॉर्म्ड आया था, वीक ह्यूरिस्टिक सर्च में इन्फॉर्म्ड आया है, इसमें ह्यूरिस्टिक सर्च भी आएगा एंड ह्यूरिस्टिक कंट्रोल स्ट्रेटेजी भी आएगा. उसमें ब्लाइंड कंट्रोल स्ट्रेटेजी है, इसमें ह्यूरिस्टिक कंट्रोल स्ट्रेटेजी है. उसमें अनइनफॉर्म्ड सर्च है, इसमें इन्फॉर्म्ड सर्च है. उसमें ब्लाइंड सर्च है, इसमें ह्यूरिस्टिक सर्च है. So these are the differences that will be coming as far as direct and weak are concerned. Under weak, these techniques are helpful when they are applied properly to the right type of the task. They usually require domain specific information. So obviously when it comes to the informed type of search, they are always domain specific. Whereas in case of uninformed search algorithm is concerned, they are not a domain specific information. When we say that there is no domain specific information, means it is not exactly what the domain is having. It is having a rough information that has been around. But in case of weak, you require a domain specific information. That is what the thing is about. So this is the actual differences between direct and weak. So in direct, there is a blind search, uninformed search, blind control strategy. It is not possible to require most of the time where memory and time is more. They include breadth first and depth first. Then case of weak, we have an informed search, we have heuristic search and heuristic control strategy. They are require domain specific information. And most important thing is that we have to look out that which type of search technique should be applied to a particular application, or I could say that which is the right type of search technique for a particular type of task. That has to be defined. This is the most important as far as heuristic search techniques are concerned. So under this, now we are going to see, we have already seen hill climbing, CSP, simulated annealing, and best first search. So now we are going to see the hill climbing, which is one of the heuristic search techniques. So two categories we have seen. Now we are going to see different methods of heuristic search techniques. The first one is an hill climbing. It is the technique for optimizing the mathematical problem. So you know what optimization means. Mostly you do an optimization in order to remove the errors. So when you take to the optimization, then mostly this hill climbing technique is used for optimizing the mathematical problem. It is widely used when good heuristics are available. So we have seen how heuristic works out. It works out with the help of heuristic functions. We have also seen how these heuristic functions are used as far as node calculation or for the node application is concerned. We have seen the examples. So obviously this hill climbing can be widely used if you have a good heuristic that is available. That then we are seeing it is a local search algorithm that is continuously moves in the direction of increasing elevation value. It is the local search algorithm that continuously moves in direction of increasing elevation to find the mountain's peaks or the best solution to the problem. Actually, elevation value is means like I am going to increase my search in such a way that I'll get to a peak where I could find out the best solution to the problem. So इसीलिए उसको hill नाम दिया है, because it is having of a direction of increasing elevation or the value. जैसे जैसे नीचे से ऊपर ऊपर जाएगा वो वैल्यू उसकी एलिवेशन वैल्यू उसकी बढ़ती जाएगी, जिसको हम इंक्रीजिंग वैल्यू बोलेंगे, और फिर वो माउंटेन के पीक वैल्यू पे जाएगा जहां पर वो बेस्ट सॉल्यूशन टू द प्रॉब्लम ढूंढने की कोशिश करेगा. जिस जगह पे वो पीक लेवल पे जाएगा वो ऐसा कंसिडर करेगा कि दिस इज द बेस्ट सॉल्यूशन टू द प्रॉब्लम, एंड हेंस द नेम इज गिवन एज हिल क्लाइंबिंग. It terminates when it reaches a peak value when no neighbor has a higher value. उस जगह पे वो पहुंच जाएगा जो कि पीक वैल्यू है, और अभी बाकी के नोड्स को उसकी लेवल की वैल्यू है ही नहीं. मतलब बाकी के जो नोड्स है एज कंपैरेटिवली उस नोड के उस पीक वैल्यू के सारे वैल्यूज लो है. जब ऐसी कंडीशन आएगी तब उसको हम बोलेंगे हिल क्लाइंबिंग हेरोस्टिक सर्च technique. So it is one of the method, it is one of the techniques of heuristic search, and it is mostly useful for optimizing the mathematical problems. It is widely used when heuristic is good, when good heuristics are available. Second most important is that continually move in the direction of increasing the elevation and the value to found mountain's peak or the best solution to the problem. And it terminates to when it reaches the peak value, when no neighbor node has the higher value than the peak value. Traveling salesman problem is one of the widely discussed example of the hill climbing algorithm, in which we need to minimize the distance traveled by the salesman. अभी हमने स्टार्ट में एक एप्लीकेशन देखा था, मतलब स्टार्ट में हमने देखा था कि जो प्रॉब्लम सर्च जो है, सर्चिंग जो प्रॉब्लम है, जो आई गिव एन एग्जांपल। 32 पे हम where I gave you, हाँ this, so यहाँ पर है देखो, this is the traveling salesman problem. So I've said that AI can be used in traveling salesman problems. So at that time I didn't explain this. Now in an applications where we are using the traveling salesman's issue, वहां पर हम लोग क्या देख रहे हैं कि ये जो हिल क्लाइंबिंग टेक्निक है, ये AI की वो टेक्निक है जहां पर वो ट्रैवलिंग सेल्समैन प्रॉब्लम को वो सॉल्व करेगा। तो ट्रैवलिंग सेल्समैन प्रॉब्लम इज व्हाट, it is one of the widely discussed examples of the hill climbing algorithm in which we need to minimize the distance of the distance traveled by the salesman. So जब हम किसी salesman को कोई task देते हैं, so the task is at the different places where he have to go and he has to sell it. Now what happens is that the distance traveled by the salesman is very large, is very huge, but the output may be not as huge as the distance traveled. So what you're going to do with the help of artificial intelligence, or I could say with the help of hill climbing technique, which is one of the search technique, they will find out the shortest path that the salesman can travel. So the shortest path how salesman can travel with maximum profit gain can be achieved with the help of hill climbing. Understanding what I want to say? See, there is a salesman. What is the task of the salesman? What is the task of salesman? Obviously the salesman wants to sell something and then he visits from places to one place to the other place. So he visits a long distance. He will visit, his travel will be a long distance, but you never know that what kind of output he might get. He may sell or he may not sell. So the distance traveled and the profit or the margin gained, they are inversely proportional to each other. So what this hill climbing technique can do is that it not only will reduce or minimize the distance traveled by the salesman, but will also help you to increase the profit which he can gain by selling the product. That is how it is made. It is also called as a greedy local search as it looks to its good immediate neighbor state and not beyond that. So greedy क्यों बोलते हैं? वो दूसरी तरफ ज्यादा देखता नहीं है, वो आपके नेबरिंग नोड की तरफ देखेगा और उस हिसाब से वो अपना काम करता रहेगा, उसके उसके बियॉन्ड वो नहीं देखेगा. It will not see beyond those nodes. So it is having the neighboring nodes and it will see only those nodes in order to go for the local search. So hence it is also called as a greedy local search. हमने इससे पहले भी greedy first fit search algorithm देखा था. So again उसमें greedy जो word है वो वही है कि it will try to search through the neighboring nodes. It will try to search through a neighboring node and will not go beyond that. And henceforth it is called as the greedy local search. Now, what are the steps that comes under hill climbing? So you can see that there are three triangles. So one is your features, the second one is a type, and third one is the problems. Now this is how the hill climbing is. So what does this hill climbing means is that it will reach increasing its efficiency up to that point where it will have the peak value as compared to the other values. So getting to the peak in order to get the perfect solution to the problem is done by hill climbing. Now, what are the steps that are included in hill climbing in AI? Step one is evaluate the initial state. So obviously the first initial state will be evaluated. If it is the goal state, then written success and stop. पता चला कि वो तो गोल स्टेट है तो वो स्टॉप हो जाएगा वहीं पे. यानी कि इनिशियल स्टेट और गोल स्टेट अगर एक ही है तो वहीं स्टॉप हो जाएगा. अदरवाइज अगर वो इनिशियल स्टेट होगा तो वो गोल स्टेट तक जाने की कोशिश करेगा. जैसी गोल स्टेट उसको मिल जाएगा वो स्टॉप करेगा. सेकंड, loop until a solution is found or there is a new operator left to apply. So it will keep on searching until and unless it finds a solution, है ना. और इसका मतलब ये भी होता है कि भाई सारे ऑपरेटर्स यूज करके बैठ चुका हूं मैं, अभी नया ऑपरेटर का मुझे ढूंढना पड़ेगा, नया ऑपरेटर लगाने के लिए ढूंढना पड़ेगा. दो ही चीजें हो सकती है. एक तो आई विल कीप ऑन कंटिन्यूइंग द सर्च इन सच अ वे दैट आई विल फाइंड अ सॉल्यूशन, or the other option I can say that I have used all the operators and now I need a new operator for searching. The same thing is there in loop in step number 2. Step number 3, select and apply an operator to the current state. So now selecting the operator to be applied to the current state is one of the most important steps where you're going to apply. Step number 4, check the new state. अभी current state तो खत्म हो गया, अभी नए state की तरफ चलो. If it is in a goal state, then return to the success and quit. अगर जो नया state है वो goal state ही है, तो फिर अब समझ लो कि we can quit. So अब वो न्यू स्टेट पर लगा चुका है सब एल्गोरिदम, अब वो करंट स्टेट पर लगा चुका है, अब वो अगले वाले स्टेट की तरफ देखेगा, यानी कि चेक द न्यू स्टेट. इफ इट इज द गोल स्टेट तो वो अचीव हो गया, सॉल्यूशन मिल गया वहां तक, इट विल रिटर्न टू सक्सेस एंड देन इट विल क्विट. Else if it is better than the current state, the assign a new state as the current state. लेकिन अगर उसको बेटर सॉल्यूशन नहीं मिलता है तो वो करंट स्टेट को छोड़कर नए स्टेट की तरफ जाएगा और नए स्टेट को करंट स्टेट बोल के दिखाएगा. Else if not better than the current state, then it will return. लेकिन करंट स्टेट से बेटर अगर है नहीं है वो, तो करंट स्टेट पे रहेगा और स्टेप नंबर 2 पे फिर से एक बार जाएगा. Is it okay? The algorithm is simple, not as complicated. First क्या देखा हमने? फर्स्ट ये देखा इनिशियल स्टेट को असाइन किया. अगर इनिशियल स्टेट और गोल स्टेट दोनों सेम है तो वो रुक जाएगा और रिटर्न हो जाएगा. दूसरा, द लूप विल कंटिन्यू अंटिल अ सॉल्यूशन इज फाउंड. द सर्च विल बी कंटिन्यूड अंटिल अ सॉल्यूशन इज फाउंड. Or I could say that all the operators are used and it is searching a new operator. Same thing like what is been until a solution is found. Then select an operator and apply the operator to the current state. Go for the next state. If the next state is a goal state, then it will return and quit. Else, if it is found that a new state is better than the current state, then the new state will be assigned as a current state. And if it is found that the current state is better than the new state, then it will keep on the current state and return to step number 2. Is it okay? Step 5 will be exit. So this is how the hill climbing algorithm works out to be. Now after hill climbing, the next one is a best first search. That is also called as BFS. This algorithm always chooses the path which appears best at the moment. यानी जो पाथ उस वक्त उसको लगा कि ये बेस्ट है वो चूज करेगा. दैट इज द मोस्ट इंपॉर्टेंट थिंग. उसके बाद वाला पाथ भी अगर बेस्ट होगा तो वो बात की बात है. दैट इज द थिंग दैट इज टू बी थॉट आफ्टरवर्ड. बट अप टिल दैट whatever the path he has searched, and out of all those paths he find that this is the path which is best at the moment, it will choose that path. It is the combination of a depth first search and breadth first search algorithms. So obviously DFS and BFS, it is the combination of these two will result in BFS. We have already seen those two. It lets us to take benefit of both the algorithms. So दोनों के भी advantages को combine करके एक अच्छा method बनाने की कोशिश करेगा. It is uses the heuristic function and search. At the same time, it not only uses the DFS and BFS, but it also uses the heuristic function. With the help of the best first search, at each step, we can choose the most promising node. So, अगर BFS की बात करते हैं, best first search की बात करते हैं, तो बेस्ट फर्स्ट सर्च जो है ये दोनों मेथड्स को अप्लाई करके जो बेस्ट नोड है वो चूज करने की के लिए ये दो एल्गोरिथम्स का यूज करेंगे. Now what are the steps that are included into it? So all these algorithms, yeah, all these search algorithms will be having some of the points that are common, whereas rest are been changing according to the logic that is built up. Now in case of best first search, the step number 1 is place the starting node into the open list. So there is a list called as an open list and closed list. There are two types of lists is there. So while when we are moving towards the closing of the algorithm, we will be going towards the closing node, closing list. But when we start with the start node, then we have to start with the open list. So placing that start node in the open list is the step number 1. Suppose if the open list is empty, then stop and return failure. Okay. So if you find it is an empty, then we will stop there and then we will return the failure. Third step, remove the node n from open list, which has the lowest value of h of n, and place it to the closed list. So बहुत सारे nodes होंगे open list में. वो क्या करेगा? सबसे पहले heuristic टेक्निक से वो सबसे पहले लोएस्ट वैल्यू ढूंढेगा जो हम ढूंढते आए हैं. हमने देखा ना heuristic फंक्शन कैसे काम करता है. सो लोएस्ट वैल्यू ढूंढेगा और उसमें से उसको निकालेगा वो ओपन लिस्ट में से और क्लोज लिस्ट में डाल देगा. बराबर. ये 3 स्टेप समझ में आ गए. पहली स्टेप ये है, स्टार्ट नोड को ओपन लिस्ट में डालेगा. अगर ओपन लिस्ट एम्प्टी है तो वो फेलियर रिटर्न करेगा. तीसरी बात, वो रिमूव करेगा वो सारे लिस्ट एन नोड जिनकी वैल्यू लोएस्ट है, ओपन लिस्ट से उठाएगा और क्लोज लिस्ट में डाल देगा. स्टेप नंबर 4, expand the node n and generate the successor of node n. So expand the node n and generate the successor of node n मतलब क्या? वो वाला नोड ढूंढो जो आपको आगे सक्सेस की तरफ लेकर जाएगा, है ना. बहुत सारे नोड्स होंगे, बहुत सारे लूप्स होंगे. सो आपको आइडेंटिफाई करना है दैट नोड. यू हैव टू आइडेंटिफाई दैट नोड विच विल हेल्प यू टू रीच टू द सक्सेसर ऑफ दैट नोड. ठीक है. Step number 5, check each successor of node n and find whether any node is a goal node or not. क्या करेगा? वो नोड ढूंढेंगे जिससे आपको सक्सेस मिलेगा आगे चल के, और फिर वहां पर हम चेक करेंगे कि whether the successor node is having the goal node or not. First of all, we are going to find out a node which will be help to get a successor node. And then this successor node will be helpful to find out the goal state. If any successor node is a goal node, then return the success and stop the search. वहां पर आपको मिल गया नोड, अभी स्टॉप करो. For each successor node, the algorithm checks for evaluation function and then check if the node has been either opened or closed list. हर नोड जो सक्सेसर नोड है वहां पर उसकी वैल्यू चेक होगी और वो भी चेक किया जाएगा कि whether वो ओपन में है या क्लोज में है. If the node has not been in both the list, then add it to the open list. अगर वो नोड दोनों लिस्ट में नहीं है तो आपको उसे ओपन लिस्ट में ऐड करना पड़ेगा. And then it will back to the step number 2. Again, open list will be checked. If it is empty, return failure. If it is not empty, check the lowest value of h of n, place it in the closed list. Expand the node in such a way that you will find out a successor node. Check each successor node and find out whether any node is a goal node. If the successor node is a goal node, then return success and stop the search. If each successor node, the algorithm check for evaluation function, then it is found that if both the nodes are not in open or closed search, then you add that node into the open list. This is how the best first search algorithm works out. You will be finding all the logical things in unit number 2. These algorithms are all logical based. They have some techniques, they have some methods. Third number, A star search. We have already seen like this A star search in uninformed and informed search algorithms. So A star search utilized heuristic search and uniform cost function method. Do you remember yesterday I've explained you how those things combinedly working for the A star search algorithm. It is one of the best algorithms, right? They say uniform cost search plus heuristic search दोनों को combined करके वो A star search algorithm बनाता है. अभी यहाँ पर A star search में हम लोग देखेंगे कि इन्होंने कौन सा टेक्निक यूज किया है. Remember, there are two different things. One is A star search in case of informed and uninformed search algorithm, and A star search in heuristic search techniques. So there are two different things, two algorithms. A star search is most commonly known form of best first search. So अभी अभी हमने जो BFS देखा है उसी फॉर्म में ये भी आता है. It uses the heuristic function h of n and cost function to reach to the node from the start gn. So इसका मतलब ये भी वही टेक्निक पे काम करता है जो A star search वो हमने देखा था स्टार्ट में. So ये भी वही टेक्निक पे काम करता है, ये भी वही करेगा, मतलब ये भी ह्यूरिस्टिक फंक्शन लेगा और कॉस्ट फंक्शन लेगा और ये दोनों की मदद से वो A star search करेगा. That means it will start from the start node called as g of n. It will utilize heuristic function h of n. It will utilize the cost function u of n. Understanding? So all these methods are combined together, and these two methods will give you the A star search algorithm. It has a combined feature of UCS and greedy best first search by which it can solve the problem efficiently. So it is also having this UCS means जो ऊपर वाला देख रहा है ना ह्यूरिस्टिक और कॉस्ट फंक्शन, उनका कॉम्बिनेशन करके ग्रिडी बेस्ट फर्स्ट सर्च का भी वो इस्तेमाल करेगा. सो हम ये देख रहे हैं कि बहुत सारे सर्च एल्गोरिथम्स है, वो कॉम्बिनेशंस ऑफ डिफरेंट सर्च एल्गोरिथम्स है, एंड दीज कॉम्बिनेशंस आर डन व्हाई बिकॉज दे वांट टू गेट अ perfect solution to the problem. It finds the shortest path through the search space using heuristic functions. So obviously it is going to find out the shortest path through which the search space algorithms can be found out. These search algorithms expand fewer search trees and gives optimal results faster. So obviously the search will be in the form of a tree, as we have already seen how nodes and the trees are been formed and how the search algorithms works out to get some optimal results, to get results faster. Now, what are the steps here? What is the algorithm of A star search? So quite a similar to what we have seen. Here also we have an open list. Here also we have a closed list. So the closed list is near to the closed, and open list will be near to the opening or the start node. Closed list will be to the goal node. Okay. So what are the steps? Step number 1. Place the starting node in the open list, exactly same way we have done. Step number 2. Check if the open list is empty or not. If list is empty, then return failure and then stop. This is also we have done. Same thing. Now, third thing is select the node from open list which has the smallest value. This is also we have seen. So वहां पर हमने h of n का smallest value देखा था. अभी यहाँ पर हम h of n नहीं ले रहे, हम यहाँ पर g plus h ले रहे हैं. फर्क समझ लो. वहां पर हमने h of n लिया था जो कि ह्यूरिस्टिक फंक्शन था. यहाँ पर हम स्मॉलेस्ट वैल्यू ऑफ इवैल्यूएशन फंक्शन ले रहे. वहां पर हमने ह्यूरिस्टिक फंक्शन लिया था, वहां हमने h of n लिया था, यहाँ पर हम g of h ले रहे. If the node n is the goal node, if you find that the smallest value is a goal node, then return the success and stop. Otherwise, मिल गया हमको goal node. अगर ऐसा नहीं होता है, then expand the node, find out the successor. For each and every successor, check whether n is already present in open or closed node. If not so, then place it in the open list. Same thing what we have done there also. यानी कि यहाँ पर वहां पर और यहाँ पर तकरीबन सेम चीजें है. Only difference is that smallest value of h of n is taken there, and here the smallest value of evaluation function g plus h is taken. Otherwise the successor is going to be, you are going to find the successor node, and if the successor node is the goal node, then you can stop, because you can terminate, because you have, your search is complete. Then it is also found that if the n node which is not been available in open or closed, then you have to put that n in the open list. Okay, else if the node n is already in open, agar wo already hai in open as well as closed, then it should be attached to the back pointer which reflects the lowest gn dash value. यही एक स्टेप है जो अलग है स्टेप नंबर 3 और स्टेप नंबर 5. ही इज सेइंग कि अगर n ओपन लिस्ट और क्लोज लिस्ट में नहीं मिलता है तो n की वैल्यू ओपन लिस्ट में डाल दो. अगर ऐसा कंडीशन नहीं आता है कि वो, सपोज इफ n नोड इज ऑलरेडी प्रेजेंट इन ओपन एंड क्लोज, then it should give a back pointer which will reflect the lowest gn dash value. That is what the fifth step number is. मतलब क्या है, अगर नोड ओपन और क्लोज में नहीं है तो नोड n को उठाओ, ओपन लिस्ट में डाल दो. ओके, दूसरा बात है कि अगर n नोड ये ओपन लिस्ट में भी है और क्लोज लिस्ट में भी है, तो एक वैल्यू वो रिटर्न करेगा जो कि लोएस्ट वैल्यू होगी, और वो gn डैश होगी. और g ऑफ n और h ऑफ n हम जानते हैं वो कॉम्बिनेशन है इवैल्यूएशन फंक्शन का. हैव यू गॉट इट? And then it will be written to step number 2. Now we'll go to the method number 4, called as the simulated annealing. So simulated annealing is nothing but an algorithm that never makes a move towards lower extreme destined to be incomplete, that it can still out be a never by extreme. So this is one of the type of heuristic search technique that will actually never makes a move towards lower extreme. इसका मतलब यह है कि वो लोअर वैल्यू की तरफ कभी जाएगा नहीं, फिर वो इनकम्प्लीट रह गया तो भी चलेगा. It will go near to the extreme. It will never go to the lower extreme. It will go maximum to the nearby extreme. Also, on the off chance that calculation applies an irregular stroll by moving and replacement at that point, it might be finished yet not proficient. Obviously, the calculations applies here are on the irregular stroll. When you move it towards the lower extreme or to the nearby extreme, it might finish, but it might not be proficient. इसका मतलब क्या है कि वो नियरबाय एक्सट्रीम के जा सकता है, मगर it might not be finished in proficient. मगर वो it will not move towards the lower extreme. That is what it does mean. Mimicked annealing is the calculation that yields both proficiency and culmination. So this annealing actually is also called as a mimicked annealing. It mainly depends on both the things, that is how proficiently it is working and how culmination it is, right? So culmination and proficiency, both the things are very important as far as the annealing mimicking is calculation. So what does it mean is that you need to be very proficient, as well as you need to have the culmination. So if both the things are there, then only we can say that it is perfectly carrying out the thing. Okay. So now one thing I would like to clear here is the proficiency has to be the most important thing as far as the culmination is concerned. So if both of them are together, then it might be an irregular while doing the proficiency. At that time, it becomes most important thing. Now, in terms of metallurgy, annealing is a procedure of solidifying a metal. If you go in case of metallurgy, then what annealing actually means? It is nothing but procedure of solidifying a metal or glass to high temperature at that point, cooling bit by bit, so this permits a metal to arrive a low vitality crystalline state. अगर एग्जाम्पल ले कि एनीलिंग का मतलब क्या है, हम यहाँ पर सिमुलेटेड एनीलिंग कर रहे हैं, तो सबसे पहले एनालिंग की बात अगर काम हम करें तो एनालिंग कैसे समझ सकते हैं कि वो एक प्रोसीजर है जो एक मेटल या ग्लास को सॉलिडिफाई करता है। पहले वो हाई टेम्परेचर पर जाकर बाद में उसको कूल किया जाता है बिट बाय बिट, धीरे धीरे से, and then it permits the metal to arrive a low vitality crystalline state. This is what it is called as annealing. So same kind of method, same kind of technique comes into this annealing, and hence this annealing is called as simulated annealing. A similar procedure is utilized in reenacted toughening, in which calculation picks an arbitrary move rather than picking the best move. In that event, that irregular move improves the state at that point, it follows the similar way. Although as we find that it is an irregular stroll or it might be an irregular move, but it improves the state. And it improves the state and it follows in the similar way. उसका काम करने का तरीका बिल्कुल वैसा ही है और वो धीरे धीरे improve करता है state के ऊपर. So now, after that, we are going to see examples of heuristic search where we can use this heuristic search in everyday life. So where it is been used? So if we use examples of heuristic, it can be used in stereotyping. It can be used in educated guesses. You can use the guess for education in education field. There also heuristic search can be used. Rule of thumb. So you know where laws are made with the rule of thumb. The working is done with the help of rule of thumb. There also you can apply the heuristic search. Profiling, common sense. These all things are the examples of heuristic search in everyday life. If we go in detail, what actually common sense means, where it is actually applied, how the things are. So when I say that heuristic is an example of common sense is an example of heuristic search in everyday life, what this common sense means, it is the heuristic that is used to solve a problem based on observation of an individual. So individual का observation देखकर उस problem को solve करने की जो क्षमता है उसे हम common sense बोलते हैं. So heuristic search का ये एक example ही है. Common sense is an example of heuristic search. So how it is? It is used to solve a problem based on observation of an individual. Then comes rule of thumb. This heuristic allows an individual to make an approximation without being an exhaustive search. एक approximation value निकालने का काम करता है, क्योंकि बहुत सर्च में जाएंगे और आपको कुछ हाथ ही नहीं लग रहा है इतना एग्जॉस्टिव सर्च करने के बाद भी, तो it will be difficult. So it will be rule of thumb is an example of heuristic because that will help you to make an approximation without going to the exhaustive search. Understanding what I want to say? Then comes working backyard. Now working backyard means it lets an individual solve a problem by assuming that the problem is already being solved by them and working backward in their minds to see how much a solution has been reached. So working backward मतलब क्या कि ये assume करके चलना है कि ये problem का solution हमारे पास already है और बाद में check करना कि हमने जो solution दिया है क्या वो correct है या नहीं है, या हम उस solution तक पहुंचे या नहीं पहुंचे. That is called as the working backward. This is yet another example of heuristic search. Availability heuristic. It allows the person to judge a situation based on example of the similar situation that comes to the mind. बिल्कुल. तो ये past data से जाएगा, historical data, जो situation उसने पहले face किया है और जिस तरह से उसने उस situation को react किया है, similarly आने वाले situation को वो search out करेगा और उसी तरह से react करने की कोशिश करेगा. That is judging a situation based on the examples of the similar situations that comes to the mind. Familiarity heuristic. It allows a person to approach problems on the fact that an individual is familiar with the same situation. So one should act similarly as he has acted in the same situation before. I'm knowing a fact that how I am been familiar with the same situation, which exactly this time has occurred. So I'm going to behave in the same situation like I've reacted in that situation. Educated guess. It allows a person to reach to a conclusion without doing an exhaustive search. Using it, person considers what they have observed in the past and applies that history to the situation where there is no any definite answer that has decided yet. So they will reach to a conclusion when they are not knowing, when they are knowing that it is not, means you cannot have a conclusion there. And there is an exhaustive research, but somewhere you have to reach to the conclusion. So that educated guess is nothing but reaching to that conclusion where there not might be a definite answer or the answer may not have been decided yet. In those situations also can be used as example of the heuristic search. So this is called as the heuristic search examples in everyday life. Now we'll move on to the next point. We are in the similar heuristic search technique, but this heuristic search techniques will be moving towards the types of heuristic search. So this heuristic name is now should be remembered by you because it is coming so many times now. A number of times I'm using this word. So how important this word is, you might be knowing this. That is nothing but heuristic. So what are the types? So there are different types of heuristics available. One is availability heuristic, effect heuristic, and representative heuristic. Each type of heuristic plays an important role in decision making. Let us discuss some of them. The first one is availability heuristic. The availability heuristic is said to be judgment that people make regarding the likelihood of the event based on the information that quickly comes into the mind. So availability मतलब मेरे दिमाग में जो है, suppose what happens is that कि I have been in this situation in last week where I had a war with somebody. So that is in my mind. Suddenly somebody comes and start reacting in the same way. Then I remember the same situation which I was there. So same quickly comes into my mind. So I'm going to correlate. I'm having a likelihood of the event that is based on the information. And then making judgment of those people. This is where I reacted to that people. So this is called as the availability heuristic. On making decisions, people typically rely on the past knowledge or experience of the event. Obviously, in that situation, how I have reacted, how I have behaved. So I'm going to rely on that knowledge. It's not necessary that I may react in the same way, but yes, that will quickly come into my mind that yes, while taking decision that this has happened with me earlier. It allows a person to judge a situation based on the example of similar situation that comes into the mind. Second one is a representative heuristic. It occurs when we evaluate an event probability on the basis of similarity with another event. It occurs when we evaluate an event's probability on the basis of its similarity with the another event. Similar type of event मेरे साथ हुआ था, लेकिन वो अलग तरीके से हुआ था, एक अलग इवेंट था. उसके बीच में मैं प्रोबेबिलिटी ढूंढने की कोशिश कर रहा हूं वो इवेंट के लिए जो ऑलरेडी हो चुका है. उन दोनों के बीच में कोई प्रोबेबिलिटी ढूंढने का काम कर रहा हूं मैं. That is called as representative heuristic. That means I am evaluating the event's probability on the basis of similarity with the another event. That is called as the representative heuristic. Let us take an example to understand this. Example is product packaging. Okay, as consumer tends to associate the product quality with the external packaging of the product. अगर पैकेजिंग प्रोडक्ट का अच्छा हुआ तो आप सोचते हो कि क्वालिटी है. That means the packing is so good that the product is quality product. If the company packages its product that remind you of high quality and a well-known product, then the consumer will relate that product as having the same quality as the branded product. So अगर branded quality product के जैसी ही quality of product कोई और product देता है आपको, तो आप क्या करते हो? दोनों के बीच में सिमिलैरिटी ढूंढने की कोशिश करते हो. अरे ये तो सेम क्वालिटी ऑफ प्रोडक्ट है, तो उसके जैसा ही जो ब्रांडेड क्वालिटी ऑफ प्रोडक्ट के जैसा था. That is called as the representative heuristic. So instead of evaluating the product based on its quality, consumer correlates the product quality based on the similarity in packaging. है ना? ऐसे क्या बोलते हैं, रेडिफ वाले ने कोई अगर भेजा है प्रोडक्ट और उसको बहुत अच्छी तरह से पैक करके भेजा है जैसे ब्रांडेड वालों ने भेजा था, तो वो क्वालिटी नहीं देखेगा, सिर्फ उनकी पैकिंग की स्टाइल के हिसाब से सोचेगा कि ये भी क्वालिटी प्रोडक्ट है. That is called as the representative heuristic. The third one is an affect heuristic. It is based on the negative and positive feelings that are linked with certain stimulus. Positive and negative feeling. It includes quick feeling that are based on past beliefs. So कुछ तो मैंने दिमाग में सोच के रखा है past में. So वो जो feeling है वो आप कैरी कर रहे हो. उस सिचुएशन में जो फीलिंग थी वो फीलिंग मैं कैरी कर रहा हूँ, और वैसी सिचुएशन मुझे अभी लग रही है तो वही फीलिंग मुझे आ रही है. That is called as the affect heuristic. Its theory is one emotional response to the stimulus that can affect the decision taken by the individual. So ultimately what is going to happen is that the similar kind of situation I am there, the emotions that are been attached with that situation I am linking here with, and then what will happen is that it will affect the decision. Obviously I am correlating with it, and that's why it's affecting the decision. When people take little time to evaluate a situation carefully, they might base their decision based on their emotional response. So थोड़ा सा रुक के आपने अगर सिचुएशन को केयरफुली अंडरस्टैंड करके डिसीजन लिया या इवैल्यूएट किया, so that is better, because what will happen is that in that situation, if you are going to correlate the things with your past emotions, then the current situation you are going to respond with the same kind of emotional response. That is called the affect heuristic. Now, what is the example of affect heuristic? It could be easily understood by the help of example of advertisements. खेलते हैं ना आपके emotions के साथ? A small car, a family car. That's what these companies attacked on you on emotions. और फिर आप क्या करते हो? आपके इमोशंस के साथ वो खेलने लग जाते हैं, और उस इमोशंस में बहकर आप अपनी डिसीजंस गलत भी ले सकते हो सकता है कि वो एडवर्टाइजमेंट आपको इमोशनली बहुत लगती हो अच्छी और पॉजिटिव फीलिंग क्रिएट करती हो, लेकिन हो सकता है कि आपका डिसीजन लेने में वो गलत हो. Like the advertisements can influence the emotions of a consumer, so it affects the purchasing decision of the consumer. Exactly what I said. The most common example of the advertisement that are ads for the fast food. You know that fast food is not good, but the way they give an advertisement about the fast food, you're emotionally connected with it, and then you start taking it. When the fast food companies run the advertisement, they hope to obtain a positive emotional response that will push you to positively view their product. This is all working around you. I'll tell you, artificial intelligence is all around you. It is like in each and every situation you're facing, in each and every event that has been happening, the AI is going to be there everywhere. So tomorrow's future is AI. You are seeing that what is happening around. They are playing with the emotions, they are playing with the events, they are playing with the thoughts, everything they are playing with. So the three types of heuristic search techniques we have seen. This is the availability heuristic. The second one is the representative heuristic, and the third one is the effect heuristic. So if you understand the examples of these heuristics, you can easily understand the types of heuristic search techniques. So constraint satisfaction problem can be applied in case of, hello, am I audible? Hello.
Sir,
Am I audible? Na? No problem at all. Na?
no, sir.
Okay. So This Sudoku example is a very much example of an AI only, but we will actually take it to an example of constraint satisfaction problem. So there will be a square, there will be some empty squares in it, and some of the squares are filled with values. Now this empty square you have to find out with the help of this filled square. That is nothing but Sudoku. So Sudoku game can be easily designed or can be easily as an example of CSP. You are expected to fill the empty squares with numbers ranging from 1 to n in such a way that no row or column or a block that has number repeating itself. So obviously no number should be repeated from 1 to 9. If you're using two number, then it should be used once only. So every number has to be used once only. You cannot repeat. This is very basic constraint satisfaction problem. Now this type of problem is called as constraint satisfaction problem. So from this example, you can easily understand what is constraint satisfaction problem. You are supposed to solve the problem keeping in mind some constraint. है ना, कुछ empty square है, कुछ fill up square है, तो कुछ constraint आ गए ना आपको. Constraint क्या आ गया कि 1 से 9 तक नंबर जो है वो आप एक ही बार यूज कर सकते हैं, बार बार नहीं यूज कर सकते, तो वो कंस्ट्रेंट है. आपको जो वैल्यूज जो दिए हैं उसी वैल्यूज का इस्तेमाल कर कर बचे हुए एम्प्टी स्क्वायर्स का इस्तेमाल आपको करना है, वो भरने हैं, आपको फिलअप करने हैं. तो इट इज अ कंस्ट्रेंट. सो दिस how you are going to satisfy this constraint problem is nothing but CSP. So you are supposed to solve a problem keeping in mind some constraints. The remaining squares that are to be filled are known as variables. Obviously, that we are going to search out, those are variables. And the range of the numbers are from 1 to n. That can fill them is known as domain. Variables takes on the value from the domain. The conditions governing how a variable will choose its domain are known as constraints. So you're going to put a conditions. So how the conditions is, how you're going to choose this variable, that is nothing but constraint. CSP is a problem that requires its solution with some limitations or conditions known as constraints. Now, this constraint satisfaction problem can be understood with the help of set of equations. It consists of following finite set of variables which stores the solution. So V is equal to V1, V2, V3 till Vn. A set of discrete value known as domain from which the solution is picked. ये जो है ये variables है. ये discrete value है जो कि domain में से है. That is D1, D2, D3 till Dn. So a finite set of constraint is to be designed like C1, C2, C3 to Cn, where each can involve number of variables Ck, that is the power set of D, इसमें से true or false till a condition k equal to 1 to n. So ये C1, C2, C3, C4, C5 दिया जाएगा with a power set of D. So D1, D2, D3 till Dn. The condition is that whether it is true or false. This condition is nothing but constraint satisfaction problem condition. The element in this domain can both be continuous and discrete. Both in AI, we generally deal with the discrete value. Both continuous as well as discrete value can be used in AI, but mostly we will follow discrete values. Also note that all these sets should be a finite except for the domain set. ये finite भी होना चाहिए, infinite value का मतलब नहीं. हाँ, मगर domain set आपका infinite हो सकता है, बाकी की चीजें आपको finite रखनी पड़ेगी. Each variable in the variable set can have a different domain. So ये different domains हो सकता है, हर variable को different domain हो सकता है. For example, consider a Sudoku problem again. Suppose that row and column and block already have 3, 5, 7 filled in. So 3 number, 5 number और 7 number का block भर चुका है. Then the domain for all the variables in that row, column and block will be. तो अब domain क्या होगा? ये 3, 5, 7 जो है ये variable हो जाएंगे. बराबर। तो डोमेन क्या होगा, बचा हुआ, जैसे 1 2 4 6 8 and 9। नाउ पॉपुलर प्रॉब्लम्स विथ सीएसपी, और कुछ पॉपुलर प्रॉब्लम्स है क्या? यस, देयर आर प्रॉब्लम्स विच कैन बी सॉल्व विद द हेल्प ऑफ CSP. What are they? Crypt arithmetic, that is coding alphabets to numbers. N-queen. In an n-queen problem, n queens should be placed with nxn matrix so that no queen shares the same row, columns, or diagonal. So it is a type of an game only that can be solved with the help of CSP. Map coloring, coloring different regions of the map, ensuring no adjacent regions have the same color, like your global map. That can be done with the help of CSP. Crossword, that the puzzle you share in the newspaper, that is can be also solved with CSP. Sudoku, a number grid, and Latin square problem. This is also yet another type of a problem which can be solved with CSP. CSP can be also used for the search problem. CSP can be used as a search problem. The domains and variables together determine a set of all possible assignments and can complete or partial. Finding the one that satisfies all the constraint in search problem, like finding the shortest path between the two nodes in the graph. So CSP search problem में कैसे use हो सकता है? So it can be used in order to find out the shortest path between the two nodes in the graph. The CSP search graph node represents the assignment, and an edge from node to vertex corresponds to change in a single variable. So it is going to go from one node, particularly from edge to the vertex in a to the change in the single variable. The start node is an empty solutions with all variables unassigned. Each time when we cross an edge, we change the value of exactly one variable. The search stops when we find the complete assignment that satisfy all the constraints. And the constraint satisfaction checks corresponds to the goals test in the general search. We can visualize the CSP and the structure of its solution as a constraint graph. If all constraints are binary, then the node in the graph represents CSP variables and the edge denotes a constraint acting upon all that. See, this is all the algorithm that has been carried out. However, if the constraint involves more than two variables, we create a constraint hypergraph. So अगर एक वेरिएबल पे काम चल रहा है तो आगे वो जो algorithm है वो काम करेगा. अगर एक से ज्यादा दो वेरिएबल्स होंगे तो फिर कंस्टेंट हाइपर ग्राफ्स के ऊपर जाएंगे. अदरवाइज कंस्टेंट ग्राफ के ऊपर हम एक वेरिएबल पे काम कर सकते हैं. They contain two types of nodes, the regular nodes that represents variable and the hyper node that contains represents the constraints. So this is how the CSP as search problem can be studied. So I do feel so we have taken a lot of things today. So in the next, we'll be going for the stochastic search, and then there will be gaming, how gaming algorithms works out. So these things will be done. So I do feel so I will stop the thing and we will take the attendance.